Okay, I'm going to talk to you about using openocd to debug the code on the STM32F103 breakout board. Before I start, here's the layout of the directory I'm using. The Blinky program is in this directory here. At the same level as that directory is an include directory where all the header files are going to be, some data sheets, and other examples I've been working on we'll talk about. The configuration files for openocd are here also. This one here is the top level one, which includes this one, and then some development notes I made as I went along. Also still here is the SVD file from ST Microelectronics for this particular device. Anyway, let's go look at the code. We'll close that. And here's the code in question. Simple Blinky program. It will flash the LED on board in this main while loop here. There's a software delay here that just counts down from 1,000,000 to 0, and that takes us a couple of seconds. The LED on the board is wired up to sync current into an output, or port C bit 13 of the microcontroller. So making that port bit high turns off the LED, making it low here turns on the LED. So let's go and clear up the screen here and just talk about what we're going to do. So openocd is in the path here, so I can go openocd and specify the configuration file. In this case it's STM32F103 from AliExpress. Press enter and there it is, it's connected. This is just diagnostic information indicating that everything went more or less okay. Now if we look at the window behind this here, you'll see there's the board down there. It's connected over the ST-Link debugger interface, 4 wires, and the program is currently stopped. Now, in this window here, you leave that window open with OCD, but in this other window here, we're going to run the GNU debugger. Before we do that, I'll just show you how we build the program. You go ./build, and Windows, you just type build, and we will run the batch file here. And the Linux world, you have to specify the current directory in front here with that little /. Right, that's it built, program's ready to go. Let's start the debugger. We're using ARM none EABI GDB and this the ARM GNU debugger. You'll notice that I've already set up the path for all these programs on the system. It knows where to find them all, so you'll have to do that when you install these things. Alright, I'm in the debugger. Now, at the moment the debugger is running in this window and it's not connected in any way to the openocd session over here. They make a connection using TCP/IP. So we tell GDB that the target we want to debug is remote. Now it's still on the same machine, but using the word remote means it will use a TCP connection. And we can say localhost 3333, which is the usual port openocd listens for connections on, or you can leave out the word localhost and just use :3333 and it'll default to localhost. So now we're connected. This window changed over here, told us a little bit about the chip and the incoming connection. And here we see the status that the processor is currently stopped on that location. Now, commands we can execute here. Let's reset and monitor, reset, halt, which will reset and stop the processor in case it's already doing something. You should do that anytime you load programs. Okay, halted. Now, let's load the program. Load main.elf. Loaded. And if we go monitor reset, you should see the program running, and you can see the LED blinking down here on the right. So the program is executing that while loop with a delay, leaving the LED on, leaving the LED off, and so on. We can do a bit more than that. If we go monitor reset halt, we can also use openocd and GDB to step through the code in our program. So before we do that, we have to load the debug symbols from the executable file. So we go file main.elf. It's the same name as the program we just loaded. GDB asks us, are we sure you want to do that? Say yep. And now we can let's list main. There it is there. It shows me some of the lines at the beginning of main. There's our software delay function. If I hit enter again, it repeats the last command. And let's say we put a breakpoint in on line, say 20 there, just before it turns the LED off. So break main.c:20. Right. So continue. Notice I used the word continue instead of reset there because continuing is used when you're doing interactive debugging on your target. So we've reached the first breakpoint. we're about to execute this line of code here. It hasn't happened yet, so the LED is on because the output is currently low. And if I go next, it executes that instruction, that one line of C code, and the LED went off, as you see. If I go next again, it does all million steps of that delay function. It doesn't step into the function, it steps over it and executes it in one go. And now we're at the next line where we're going to turn the LED back on again. There it is, the LED's on over here, and the delay again. And it repeats. Now, one nice thing you can do in GDB and openocd is you can change your program and still stay in the environment. So let's go back to our editor here. Let's go change the delay to maybe make it all 10 times faster. Now, I hope my camera can keep up with that, so I'll press save. And inside GDB, we can execute commands on the shell using the prefix shell. And there's our build. That's it compiled. Now, monitor, reset, halt, stop the processor again, load main.elf, and go monitor, reset. And you can see the LED is blinking a lot faster now. So GDB is quite useful in allowing you to do some fairly fancy debugging. You can also print the values of variables, examine memory locations, and change memory locations, although it's using a text interface, which you may not be used to if you're more used to using a graphical user interface.